Welcome, everyone. Thanks for joining us live in Paris. Kyutai is a very unique place. It's a non-profit lab which is dedicated to open research on artificial intelligence. So we work on novel foundation models, and we plan to share them for the benefit of all. So it's a very important mission to us. Within 6 months, from scratch, we developed this, you will see in a sec, this research prototype, which is really an experience.
Hello, how are you today?
Hello, can you tell me your name, please?
Hi, my name is Moshi. How can I help you today?
Hi, Moshi, can you tell me more about yourself?
Certainly. I was created by the non-profit research lab Kyutai, which focuses on using AI to tackle the main challenges of modern AI.
Okay, that sounds great. Do you know what open source is?
Yes, open source refers to the practice of sharing software source code free of charge.
What are the benefits of open source?
One of the main benefits is that it enables collaboration and allows individuals and organizations to contribute to the development of the software. Hey, how's your day?
Speak with a French accent and tell me a poem about Paris.
Paris, the city of love, where time stands still, and hearts take flight. In the heart of Europe, it's in prime. The Seine River flows, a beautiful sight, as the lights twinkle and the stars glow clear.
Okay, thank you, Moshi.
That was Paris.
Okay, that was great. Now, speak with a whispering voice and tell me a mystery story.
In the shadows of the underworld, where the cold winds whisper secrets, a tale of darkness and light.
Okay.
A ray of light, a sparkle of hope.
Okay, let's try something.
A little star that cannot be heard.
Okay, can you tell me the plot of movie The Matrix?
Of course. The first movie was called Matrix, released in 1999.
Wow.
And it was about a guy named Niel who was living in a world where he discovered he was living in a simulation.
Okay, that sounds great. Yeah, okay, I don't care about the rest. I don't care about the sequels, actually.
For the last demo, we're going to try some role play.
Hello, what's up?
Hey, what's up, Moshi? Are you there?
I'm here. What's up?
Okay, so I want to do a role play. Let's pretend we're on the starship, the Enterprise, on a mission given by Starfleet. How does that sound?
It sounds exciting. Let's do it.
Great. So I'm going to be the captain, and you are the navigation officer. Our mission is to discover life on a new, distant planet. All right? All right, Moshi?
Yes, sir. Sounds like a challenging mission. I'll be ready.
Okay. So the planet is Sirius 22. Can you plot a trajectory course to it, please?
Yes, sir.
Okay. How long is it going to take us to get there?
I've mapped it out.
Okay.
It's approximately 5 months to get there.
Okay, that's not too bad. Do you think we have all we need on board the ship to start the mission?
Yes, sir. We have everything we need.
Okay, can you check that all the systems are nominal, please?
Yes, sir.
Okay. Are all the systems nominal?
Yes, sir.
Okay.
Come back to science, and I would like to tell you more about how we got there and to lift a bit the hood of Moshi with a bit of technology and science.
What we did is that instead of giving text to the model and making it produce text, we designed a new audio language model. So the way it works is that we take speech without text, just annotated speech of people speaking and so on. We compress it so heavily that it can become similar to pseudo words that we can then give to an audio language model. And this audio language model takes a small snippet of audio and is trying to predict the next segment. And if we do it enough, then the model has learned a lot, as much about speech as a text model, language model will learn about text. But we are still far from having a fully fledged conversational model. And to explain how we fill this gap between audio language models and Moshi, I would like to welcome my good friend, Alex.
So the first aspect is multi-modality. And Moshi can listen and generate audio, but it's not the only thing. It also thinks as it speaks. The second aspect, and probably the most important, is the fact that Moshi is multi-stream. There is not just one stream of audio with, like, for instance, us talking and then Moshi replying. It's actually 2 streams of audio because we want Moshi to be able at all time to speak and to listen.
To talk a bit more about how we train Moshi. We have to rely on text to acquire knowledge. The first step of training Moshi was actually to train a text-only large language model that we called Helium. The second step is actually to perform some joint pre-training on a mix of textual data and audio data. The goal here is to learn a common representation between text and audio so that the model, when the model is generating audio, it can actually use all the knowledge that it acquired by being trained on text. Once we've done these two steps, what we get is what we call a foundation model for audio. And so basically, that's a model that can take audio as input, generate audio, but at that point, it doesn't know how to hold a conversation. We need to do what's called fine-tuning on conversation data. Here, we decided to rely on synthetic dialogues to train the model. So how did we do that? So first, we started from the text-only language model, and we trained it specifically so that it could generate oral-style transcripts. Then, using those transcripts, we can synthesize them with a text-to-speech engine that we also developed in-house. Finally, we can train Moshi on that data. There's one last ingredient to get to Moshi, and it is its voice. So we wanted to give Moshi a consistent voice across interaction. And so for that, we worked with an amazing voice artist called Alice, who recorded many monologues and dialogues in different situations using different tone of voice, talking styles, etc. We can train a text-to-speech engine that can support more than 70 different emotions or talking style. And actually, we wanted to showcase to you like what this TTS engine can produce. And now what you will hear is some data that was generated with our TTS.
Hey, this time I'm not chatting, but rather being controlled by text. I can express more than 70 emotions and speaking styles.
Like whispering.
Or maybe I could sing a song.
I can sound terrified.
Or impersonate a pirate, ahoy matey.
I can even speak with a very French accent, just like my inventors.
Looking forward to interacting with you.
All right.
And so that was not recorded data, that was all generated with our TTS. Now, let me welcome on stage Laurent, who will tell you how to run everything efficiently.
Yes, thank you, thank you.
Thanks, Edouard. Moshi has a theoretical latency of 160 milliseconds. And we measured the latency from the voice of the speaker back to the headphones or whatever they use to get sound. And we measure a latency between 200 and 240 milliseconds. So that's very good for lively conversation, and that's the best in the world from what we know. And the next step is to be able to run it on device. The exact same model that you've seen, like that was running on the cloud, but no, just on device.
Hello, what's up?
Hey, can you tell me your name, please?
Oh, sure. How are you feeling today?
I'm feeling pretty well, and you?
That's great. I'm Moshi, and I'm here to help you make the most of your day.
And I've been working a bit on making Moshi a bit more compact. So what we did is essentially compress both the model weights as well as the conversation history using state-of-the-art compression techniques such as quantization. And what we find is often that the text and audio modalities kind of behave differently after quantizations. So we did have to find some ways to both evaluate and also balance a bit the discrepancy between the modalities. But once we do manage to do this, what we obtain is models which can be 2 to 4 times smaller than the original model. And
we care about safety. So one question in particular that we want to address is how to determine if an audio has been generated by Moshi or not. And for this question, we have actually considered 2 strategies. The first, when online, is quite simple. We just keep track of the audio that Moshi generates by extracting some signatures that we put into a database of generated content. The second strategy is called watermarking. And in this case, we add some inaudible marks, you can't hear them, to the audio we generate, such that we can detect them with a specific detector. So this is an active area of research.
By the end of the day, the demo will be available online. Next steps is to share all the technical knowledge with a technical paper, very detailed, and also to share the models themselves and the code for training and running and modifying, etc. So this is on the agenda. Thanks a lot, and talk to you.